Hey, what is up guys? Welcome back to another video, and in this video we're going to be continuing on with our Swift programming tutorial series, and in this particular tutorial we are going to be taking a look at unowned in Swift. Previously we looked at weak and weak self, and I said in that video we're going to cover unowned, and so here we are. Now, let's talk about unowned. Well, much like weak, unowned also creates a weak reference. I need to go to Xcode here. Yeah. All right. However, the thing about weak is that it assumes that the object being referenced can be nil. But in unowned, it assumes that the reference that the reference will never be nil. All right. So if the reference is nil when it's being accessed, then you're gonna have a problem. You're gonna get a runtime crash. Your code's gonna crash because, well, you can't access something. Something can't be nil, and then you access it in terms of a reference that's unowned. All right. Now, you should only use unowned when the object being referenced outlives the object that holds the reference. Right. So let's say you have object A and then you have object B. From object A, you're referencing object B. Well, if that reference is unowned, B, object B must outlive object A. All right. Now, the other thing about unowned is that it's typically used in scenarios where the object being referenced and the object holding the reference have the same life cycle or a very tightly related life cycle to one another. That way things can be coded in a way that it'll go smoothly. Now let's take a look at an example. I have an example here, and we have a couple classes in this example. We have a parent and a child class. So we have class parent. This has parent has a child property, which is of type child, an optional child, I should say. And it's got a D init. Now, we haven't looked at D init. What is this? Well, this is the deinitializer. This is code that gets run when your object is for example nil. When it has a nil value and it gets deinitialized. Inside of this deinitializer, we're printing parent deinitialized, or deallocated rather. So whenever the parent is deallocated from memory, boom, that's run. All right. Our second class is child. Now, inside of this class, child has an unowned var called parent, which is of type parent. This is where the reference comes in. So we have a weak reference between child and parent, and it's unowned. So this assumes that this creates a weak reference where the assumption is the reference will never be nil. All right. Now we have an initializer. This initializer takes in a parent object. And we're saying self.parent equals parent. A simple initializer that you would find in any class. And then we have our deinitializer. And we're printing child deallocated in this deinitializer. All right? Now, these objects have a similar, if not the same, life cycle to one another. These classes have the same life cycle pretty much, so we're able to use unowned here. Right below our classes, we're creating some variables. I'm gonna make some room here. All right. So we have a var parent, which is of type parent. Now we're initializing the child property of parent to a new instance of child. Okay, and then now what we're doing when we say parent equals nil, what we're doing is once it's nil, it's calling the deinit. So this will print parent deallocated and child deallocated. Now, why is this? Well, it's because of that reference, right? But the life cycle of the objects is ended at that point. So both objects are being deinitialized, and when that happens, the deinit is called. So both print statements are called. When we save our code and we run it, you can see the build succeeds, and in our console we get exactly what we expected: parent deallocated and child deallocated. All right, so that pretty much does it for unowned in Swift. Thank you all so very much for watching, and we'll see you in the next one.